Okay, so next problem here, it says the cubes are similar. So same kind of idea. What is the scale factor? So now what they're doing is they're giving us the ratio of the volumes, right? So they're saying that volume 1 over volume 2 is going to be, and again, order doesn't matter. I'm going to put the bigger one on top, 1331 over 729. Now, these are really huge numbers, okay? But again, these are representing our scale factor cubed. So if you want to just find the scale factor, to get rid of this cubed, you have to take what's called the cube root. Notice that 3 I put out front. We are typically doing square roots, right? If I had x squared, I would take the square root. There's no number here, right? No number. Well, now when you have a cube, you can't take the square root of a cube. You have to take the cube root of a cube. So we have to take the cube root of this fraction, which means we need to take the cube root of each part. The cube root of 1331 and the cube root of 729. Now, it could be that they are not perfect cubes. If they're not perfect cubes, you have to look to simplify first. But I'm going to try my luck in the graphing calculator to see if they are perfect cubes. So 1331. So watch what I do here. So in the graphing calculator, I do need to pull up the keyboard. And I have to go over to functions. And I have to go to miscellaneous. So again, make sure you follow those directions. And right here, this is called the nth root. You're allowed to click on that, and you can change what's called the index. There's the cube, 1331. And look, it is a perfect cube. It's 11. So 11 cubed is 1331. Let's try the other one. The other one I think was 729. So functions, miscellaneous, nth root. Cube root of, cube root of 729. 9. There we go. They're both perfect cubes. Excellent. So in this problem here, your answer is simply going to be 11 over 9. I do not want any decimals. Don't give me them. You could also, right, or if you flipped the order, it could be 9 over 11, whatever you want to do. Just enter one answer, though. And there's your scale factor. Okay? So this is showing you how to take a cube root. Next. Okay, here we go. It says 2 similar paint cans have diameters of 6 inches and 4 inches. The volume of the smaller can is 75 inches cubed. What is the volume of the larger can? Round to 1 decimal. So again, if you can visualize, paint cans are cylinders, right? So here is one paint can. Here's the other paint can, right? So this is the 4 inches, and that's the 6 inches. Okay, but again, it doesn't matter, right? We can use these 2 diameters to find the scale factor. So to find the scale factor, we're going to use, again, I'll put 6 over 4. I will simplify that by dividing by 2 and dividing by 2 to get 3/2. This is your scale factor. Now, this is a volume question. So immediately, I want to take the scale factor and cube it. I want to take 3/2, and I would like to cube it, which means I cube the 3, which would be 27, and I cube the 2, which is 8. This will be one of my ratios in my proportion. So this is the scale factor cubed ratio. Notice the bigger numbers on top. Let's use the word larger. So the larger number is on top, and the smaller numbers on bottom. So now over here, these will be the actual volumes. Well, they give you the volume of the smaller can. It's 75. It's the smaller volume. It goes across from the smaller number. And on top, we put our x. And now we cross multiply, divide, and solve. So when you cross multiply here, if you remember how to solve proportions, right? I'm going to cross multiply. 8 times x is 8x. 27 times 75 is 2025. And then I'll divide by 8, divide by 8. It says round to 1 decimal. So when I divide that by 8, this is what my calculator says. It says 253.125. It says round to 1 decimal. So the 2 leaves the 1 alone. That'd be 253.1, and that would be inches cubed. So if I come over here, 253.1, and again, know what you're doing here. You're doing inches cubed. It's a volume. Scroll all the way down for the volumes. There we go. Okay, next problem. So it says a bottle that is 10 inches high holds 34 ounces of milk. The sandwich shop below is shaped like a milk bottle. It's similar. How many ounces of milk could the building hold? Round to the nearest ounce. So when you talk about something holding something, right? Holds. That is a measure of what's called capacity. Capacity. And that is the same thing as volume. So this is a volume problem. So we need to first find the scale factor. Now notice in the picture they give you the height of the building. It's 480 inches. And they give you the height of the a typical milk bottle, 10 inches. So you need to simplify this, right? Cross off the zeros. That's 48 to 1. That's your scale factor. Well, when you do volume, you need to take that scale factor and you need to cube it. So you need to take 48 over 1 and you need to cube it. So 48 cubed is a big number. 110592. And then 1 cubed is 1. This will be one of the numbers in your ratio. 110592 over 1. And then the other ratio will be the actual capacity, actual volumes. Now, again, this is, what, bottle over, I'm sorry. No, wrong. The top number is the building. So building, and the bottom number is the bottle. So the 34 ounces represents the bottle's capacity. So that goes down here. We need to find how much the building holds. So we're going to, and again, this is just, a math problem, right? Because we would never fill a building up with milk. That's silly. But again, it's a similarity question. Cross multiply x times 1 is x, or 1x, but that's all done. So now this answer is just going to be our answer, 110592 times 34. And we get a super huge number, 3760128, and that would be in ounces. And there we go. So we'll put that number over here, 3760128, and that would be in ounces. And I believe that is going to be an option. Yep, right there. Option, ounces. Nice. So again, if you're working with similarity and 3D figures and it's a volume problem, find the scale factor, cube it, and then set up your proportion. Okay, let's do one more here. All right, last one. So it says a marble paperweight shaped like a pyramid weighs 0.15 pounds. How much does a similarly shaped marble paperweight weigh if each dimension is 3 times as large? So again, just quickly, if I'm going to draw like a square pyramid, so there's my small paperweight. There's my large paperweight, right? So to go from here to here, we multiplied by 3. 3 times as large. So again, they didn't give us a number, but say that this dimension was 2. If that dimension is 2, then that dimension is 6 if you need to make up dimensions. But again, to find your scale factor, it's just going to be 3. 3 over 1. Now, weighs. When we talk about weight has to do with density. Density has to do with volume. This is a volume problem. Weight involves volume. So you are going to have to take this scale factor and cube it. So 3 over 1 cubed, that's 3 cubed, 27. That's 1 cubed, which is 1. This is the first part of your proportion, 27 over 1. And again, this is the smaller paperweight. I'm sorry, why do I do that? This is the larger paperweight. This is the smaller one. So when we talk about the actual weights, we have to put the larger weight on top and the smaller weight on bottom. Well, the original paperweight, the small one, is 0.15 pounds. That goes on bottom. So then we need to put an X up here for the larger one. And again, we're getting kind of lucky here because when we cross multiply, the X is being multiplied with 1. That does not always happen, right? It's nice that it happens because 1 times X is just X and there's no division. But again, most of the time you have to divide. And 27 times 0.15, that's 4.05. and that'd be in pounds. And there we go. And again, there's no division because there was no number other than 1 in the denominator here. Okay, so we put that in our answer, 4.05, and that would be in pounds. There we go. All right, so that is your volume of similar solids, second video. Again, good luck on the homework.